Hi, we're going to go through how to create a stack class and then some programs that you can use the stack class for. So first of all, we're going to start with the stack class. And if you read the chapter, you know about how stacks work. You say, for example, a stack of books. You put the first book down, and then you add another book and another book. And if you want one that's in the middle, you've got to take the ones off the top to get to the one in the middle. So in our stack class, we're going to have a set of methods to run with this. We're going to have our stack, which is going to be the init, that creates a new stack that's empty. We'll have a push where we pass in an item that's going to add an item to the stack, a pop that will remove an item from a stack, a peek that lets you look at what the top item is on the stack without removing it, is empty to check to see if the stack is empty, and size to return the number of items in the stack. We're going to use a list as the data type for creating this. Okay, so I'm going to go ahead and open up a new file. Squeeze this down a little bit so it's not taking up so much room there. And we'll start with creating our stack class. First thing is we need to start the stack class. Usually with stacks, I capitalize the first letter of the name of the class. Then we need to do our init. Don't forget that it's two underlines before and after, and then our self parameter. We're going to do self.items equals bracket and bracket, so we create an empty list called items. Create our isEmpty method. It is empty. Again, we pass in self with all of these, and all we're going to do is return self.items equals bracket and bracket. Okay. So bracket and bracket is an empty list. If that's empty, it will return true. If it's not empty, it will return false. Then we can create our push. And this one we're passing in item on here. And what we're going to do with the push is self.items append item. Okay. We're going to use the bottom of the list for our entry and our exit. Next one is our pop. And with this one, we're going to return self.items.pop. Okay. Pop removes from the end of the list, so both of them is the LIFO, first in, or last in, first out. So the last one we appended in will be the first one that we pop off. Do our peek. And with this one, we're just going to return self.items, and then in brackets, length of self.items minus 1. Okay. So what that's saying is then get the length of self.items, subtract 1 off of it, and return the value stored in that location. And then the last one is our size. And that's just going to return length of self.items. That's our stack class. So all we're doing with this is limiting the functions that you can use on the list that we're using here to these. So you can't do anything else if you're using a stack. Take that S off of there. And that's the whole purpose of this. So I'm going to go ahead and get this saved. Specify where I'm going to put this. Okay, I'm going to save it in here, and I'm going to call it stack with the lowercase s, py.py. Okay, so that's all set. So now what we want to do is do a couple of program examples to see how the stack works. This first one we're going to do is to convert a decimal number into a binary number. Okay? So I'm going to create a new file here. I'm going to go ahead and close off my stack here because I don't need it anymore right now. We need to import our stack into our program. So I'm going to do from our stack file, import the stack class. We're going to call our function in here divide by 2, and we're going to pass in a decimal number. So our REM is for remainder stack, because what we're actually going to do is get the remainder of a division, and that's going to be our value for our binary number. So now while the DEC number is greater than 0, go ahead and process. Our remainder was going to be equal to our DEC number mod %2. So it's going to return either a 0 or a 1. Do an REM stack.push our REM. And then we need to change the value of our DEC number. So we're going to set it equal to DEC number integer division 2. Okay, that's our while loop. So what we need to do is from there build our string. So we're going to do bin for binary string equals quote quote while not rem stack dot is empty. Our bin string is going to be equal to bin string plus str rem stack dot pop. And I could have done plus equals in here. I go back and forth between the two. So this time I just didn't do that. So then once we run out of items in the stack, we'll be done with that. And then we're going to return bin string. Okay. So in our main program, all we're going to do is do a print to and then call our function and pass it a value to see if it comes back. Divide by 2, and we're going to pass in. Let's pass in an easy one on here. Let's pass in 5. Okay, we can come back and modify it and do another run on it. Okay, let me get this one saved. I need to save it in the same location where my stack ends. I'm going to call this divide by 2.py, okay, and then we'll run it. And then we get 101, which is right. So that's a 1. We don't have any 2s, and then that's a 3. So or 4, sorry. So that's 4 plus 1 is 5. Okay. We can then go in here and change this to another number. Let's say 42, and rerun it. And we get 101010. Okay. Now, and we could go in here and modify this and put in a loop to allow the person to enter numbers until they want to quit, and then print out what the values are of those. We're not going to modify this one to do that. So that's that one. Now, what if we though wanted to be able to have this work for any base? Base 2, base 8, base 16. Well, we can modify this to do that. Okay, I'm just going to modify this one here. You can retype it in if you want to, or you can follow along with modifying this one and then saving it under a different name. To do this one, okay, we're going to change the name to base converter. And besides putting in passing in the decimal number, we need to also pass in the base. Now, an easy way to do this is we're going to create a string of all the characters for the bases up through 16. So digits is going to be equal to, and then in quote marks, we're going to do it uppercase, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F for base 16. We already have our REM stack equals stack. We have while decimal is greater than 0, REM equals decimal number divided by, this time instead of 2, we're going to divide it by base. Okay. Then REM stack dot push REM, and then decimal number equals decimal number, integer division instead of 2, base. Okay, now we're going to change this to be new string rather than BIN because it's not binary string anymore. It's a based on the what we're base we're using on here. So while not rem stack dot is empty, new string, whoops, we got to change all these. New string equals new string plus str remstack dot pop, and then we return new string. So down here now we're going to change this to our base converter, and instead of just passing in one number, we're going to pass in 2. So we're going to do 2 of these. I'm going to do 25 2 for base 2, and then I'm going to take a copy of this, then there, and we're going to do 25 and change the base to 16. Okay, so let's see when we run this one. I'm going to save it first under a different name. And call this one base converter .py and save it. And then we'll run this. There we go. There's the 42, which isn't right. The 19. You see we did 42 up there and it was that. 19 would be 6, would be 15, 16, 17, 18, 19. I think that's right on there. So let me make sure here. Yep, everything's correct. So, oh, we did 20, I'm sorry, we did 25, not the 42. So that's why it was different on there. Okay, so that's why it was 11001, and then the 19 is the base 16 for 25. So if you have any questions on these, let me know. That would be let your instructor know, and then keep an eye out for other videos, or you'll see other videos on your module. Bye.